A quad is cyclic if it satisfies one of the following properties. Property number one, the vertices must lie on the circumference. Two, opposite angles should be supplementary. Meaning, if we add those two angles, you should get 180 degrees. An exterior angle of a cyclic quad should equal the interior opposite angle. The fourth one is that angles in the same segment. Now let's see what do you mean to say a quad is cyclic? A quad is four-sided figure. A triangle is three-sided. Like that. That is a cyclic quad. So we label that A, B, C, and D. The line AB and CB form a vertex, and that vertex is on the circumference. And BC and DC form this vertex here. AD and DC form a vertex here. Line segment AB and AD form a vertex there. All these four vertices are lying on the circumference of a circle. Therefore, we say A, B, C, D is a cyclic quad. That is a cyclic quadrilateral. That is a cyclic quad. Let's go and have a look what happens if we look at the cyclic quad. on that cyclic quad construction. And you can leave at A, B, C, D. A, B, C is cyclic quad. The vertices are lying on the circumference of the circle. And that will be circle center O. That will be circle center O. And we can name this O1 and name that O2. O1 and O2. Now, we can say that angle A is equal to twice, in fact, it's half angle O2, because O2 is twice A, while O1 is twice C. Therefore, the reason is that the angle at the center, the angle at the center, at circle center, is twice the angle at circumference. So the one that's the circumference should be half the angle at the center. Equally well, angle C is half the value of angle O1 the angle at center, at circle center. Now, if you add angle A to angle C, that is half angle O2 plus half angle O1. See that the half is common there. And then those two terms, we take half as a common factor, and we have angle O2 plus angle O1 this is half angle O2 plus angle O1 forms a revolution. And a revolution is 360 degrees. Half of 360, 180 degrees. We have angle on the left, angle A plus angle C1 is equal to 180 degrees. Therefore, we say the opposite angles of a cyclic quad are supplementary. Meaning if we add opposite angles on a cyclic quad, we should arrive at 180 degrees. That's that. Hope you got that. Let's go and have a look at the next one. What's a cyclic quad? What is a cyclic quad? A, B, C, D, and E there. We label C1 here, C2 there. There's a C2 there. There's a C1 there. Now, angle C1 plus angle C2 is equal to 180 degrees. And the reason is that the straight line, the straight angle there is formed. Angle C1 and C2, 180. Angle C1, angle C1 plus angle A are opposite angles of a cyclic quad. Therefore, they must be supplementary. Opposite angles of a cyclic quad are supplementary. Now, the first equation, C1 plus C2 is 180. The second equation, C1 plus A equals to 180. Therefore, it means angle C1 plus angle C2 is equal to angle C1 plus angle A, and the reason is that they are both equal to 180. Now, C2 will equal to angle A. I hope you see that when I transpose this C1, it will come here to be minus, and that will drop. Therefore, angle C2 is equal to angle A. There's C2 there. There's your angle C2 is equal to angle A. You can conclude that an exterior angle of a triangle not triangle, but the cyclic quad and exterior angle of a cyclic quad is equal to the interior opposite angle. Now this one is outside the exterior angle. And in this cyclic quad ABCD, that one is inside. It's interior angle of a cyclic quad. So what you have here, we will have a look at let's have a look at the examples or an exercise that seeks to test what we have just done. That's what we have done here. In that circle, we have that. Down. Can name that A, B, C, D, and E there. And this one here, 80 degrees there. This one here is 55 degrees. And the unknown here, C is X. The unknown here will be Y. If we have to solve for the value of X and Y, we say angle Y is equal to 55 degrees. And the reason is that an exterior angle of a cyclic quad we mean that this angle here is equal to that angle there. Going back to X, say X plus angle A, which is 80 degrees, are opposite angles of a cyclic quad, therefore they must be supplementary. Therefore, angle X is equal to the difference there. which is 100 degrees. Therefore, your x is 100 degrees. We can take the next one. Let's take this one here. Okay. Let's label that. Let's see that. Either small angle inside there is A, and then AO is parallel to DC. This here is X. This one here will be Y. And that will be 32 degrees. Now, A, B, C, D is a cyclic quad. It's obvious that A, B, C, D is cyclic because the vertices are lying on the circumference of the circle. We're also given that AB is parallel to the earth, but angle C here is 32 degrees. This must be twice this angle here at the center of the circle. Angle O must be 64. Angle O must be 64 because the angle at the circumference is half the one at the center. The one at the center is twice the circumference. But if O is the center of a circle, I hope you'll appreciate that AO is equal to OD, that's radi. So this line here is equal to that line segment there, which makes this angle to be equal to that angle. Therefore, we can get what y is. Let's name this theta for argument's sake. You say theta is equal to y, but theta plus y plus 64 degrees, not 640, but 64 is equal to 180 degrees. These are the angles of a triangle. Therefore, because these two quantities are equal, I'm going to write them in terms of 2y plus 64 is equal to 180. Don't forget that theta will equal to y there. So I write y plus y is 2y. Then 2y will equal to 180 degrees minus 64. And then that will be 1/6 is equal to 2y. Therefore, y will equal to 1/6 divided by 2. That is 58 degrees. So angle y will be 58. Theta is also 58. Now, we need to get this angle here, but AO is parallel to CD. So if I move here, I can tell that this angle is 32 here. So angle CAD will be 58 minus 32, but our interest is on X here. From A to circle center O back to D and to C, these angles are alternate. This angle is equal to that angle, alternate angles. Therefore, X is equal to 64 degrees. And the reason is that they are alternate angles. They are alternate angles, and alternate angles are equal if and only if the lines are parallel. So the lines are parallel, the alternate angles are there. So you have managed to solve for X. The top one was not X, was a Z. So we are converting that into a Z. Now, since we know the value of X and the value of Y, we know that angle B there, which is X, which is Z, angle B plus angle D must give us 180 degrees. And the reason is that they are opposite angles of a cyclic quad now we have 64 plus 58. That should give us 112. So D is 112. Therefore, angle B is equal to angle D, which is Y plus X is equal to 180. Therefore, your B, which is a Z, will be 180 minus 58 plus 64. B will be 180 minus 112 degrees. And your answer will be so Z there will be 68 degrees. So you've managed to solve for X, Y, and Z. You got your Z as 68 degrees. That will be enough for this lesson.